Hi everyone, this is Matt Ingram, now with the replication files in R for the Baller et al. Piece from Criminology. For starters, I'm going to cover a couple of preliminary points. With regards to R, even though you've already done this replication, or at least I'm assuming you've done this replication in Geoda, I assume no prior knowledge of R, so this very first session is going to be dedicated to providing a simple, basic introduction to R, including some basic procedures for loading data and manipulating data files once they're in memory. Throughout the semester, whenever we do lab work in R, I'll try to provide either a review of R or add to this introductory material in R so that we can um, sort of incrementally expand our working knowledge of R throughout the semester. If you'd like an external piece or an additional piece for reference with regards to using R, especially with regards to using R for spatial analysis, I recommend Luke Anselin's 2007 R manual for spatial analysis called Spatial Regression in R, a workbook. It's available for free from the Geoda Center, which I introduced in the very first introductory video. So if you go to that website and follow the documentation for R, you should be able to find that workbook there. Just one word of caution, make sure that it's a complete workbook. I've seen some copies online that only go through about page 80, 85 or so, and there are more than 100 pages in the workbook, probably closer to 130, 140, covering various forms of spatial regression and maximum likelihood estimation and some diagnostics. So make sure you have the complete workbook. After this first session, well, including this first session, I assume that you've downloaded and installed the R software as I instructed in the very first video. I also assume that you've downloaded all of the replication data from Blackboard and saved it into a single folder on your machine. This is your folder that you will be using as your working directory, or calling it your working directory. And then after this very first session, I assume that not only have you downloaded and installed R, and that you have all the data saved and accessible in a single folder in your machine, but I also assume that you're familiar with the content in this very first introductory session in R. So turning now to the replication steps, in this very first session we're going to cover this introduction to R, loading data, exporting data, plotting the data, and constructing spatial weights. And then in the next sessions, we'll go directly to replicating the empirical results that were reported in maps 1 through 4 and tables 1 through 4 in Baller et al. Okay, so let's move to R then. I'm going to try to open R here just as I would in if I were doing it myself. So at least on a Windows machine, you come down to the Start menu, pull up your programs. You might have a shortcut on your desktop, but if not, then pull it down here. I've got several versions installed. The most recent version is 3.1.2, so I'll click on that, and the R workspace opens up. This is your basic opening screen from R. So if you just recently downloaded and installed R from the CRAN site, then you should have this most recent version of R, 3.1.2. And as you open R, it should open to this blank workspace. You've got a cursor here. You could start typing here if you wanted to, and entering commands here. You could do that, but I strongly recommend, just as I would with any other software program, that you write your commands and your analysis in a separate document that you can edit and work with quickly, and then run your commands from there. In R, basically those extra documents, which in Stata you might call a do file, in R they are called R scripts. So you open them here either from a file pull down menu, a new script, or open script, or you can just use the button open script here. So let's open script. We'll go to my Baller et al. Replication folder, and I've got some R scripts here. These R scripts you should be able to download from Blackboard. Um, at the very least, the first 4 should be there. But we'll start here with the first one, data and weights. Just so you know, the second R script contains everything in the first R script. The third R script contains everything in the first and second, and so on up until the fourth and fifth, where each successive R script contains everything in all the prior scripts. So if you wanted to just open the R script 4, which contains the replication results all the way through table 4 in Baller et al., you could and just work through successively, but I'll just open R1 here, the first R script file, so that we can have more manageable content. So this is what the R script looks like. As you'll find out, the results display over here on the left in your R workspace. Your R script, your command, is in this window. And then if you generate any plots or graphs, they will first appear over here in the top right of your screen. I suggest you stagger your windows just so that you can see everything that's going on. But if you like some other arrangement of windows, then by all means set them up the way you would like. At the top of this R script, I've just got some basic introductory material, introductory notes, including some acknowledgments. In each of the R scripts, I'll have a basic kind of outline. If you're looking for something in particular, then skip to that particular step. For instance, if you just want to recap some lessons about loading data, then you can just skip to step 3 below. And then at the beginning of every R script, I also include some helpful commands. So for starters, you'll notice the pound sign at the beginning of many of these lines. The pound sign operates as a comment symbol, so everything that appears after the pound sign will not be executed in this R script. If you're familiar with Stata, this is very similar to the asterisk. Also, there's a help search command. This is very helpful if you the only requirement is that you remember the command. So basically, if you had a command like LM, which stands for linear model, that's your basic OLS command, but you couldn't quite remember the syntax for the command, then you would type help.search, open parentheses, open quote, LM, close quote, close parentheses, and that would bring you up a help page for the LM command. You can also type question mark LM or double question mark LM. Also, if you don't remember what your current working directory is, you can type get wd, open and close parentheses, and that will give you your current working directory. And then Control R runs whatever highlighted portion you have in your R script. So for instance, if I highlight get working directory, and at least on a Windows machine, hit Control R, on a Mac, I'm assuming this is Command R, but if we hit Control R, then you'll see over here in the R workspace where the results appear that my current working directory is this one, Documents. Also, R operates by generating objects. Basically, every command is set up to generate an object, and then you execute other commands in order to perform operations on that object. If you have a particular object in memory and you want to remove that object, then RM removes that object. And then oftentimes R requires you, if you want to, well, R requires you to specify an object and then an element within that object. So for instance, if you want to list a particular variable in a data set, then you have to list the object and then the variable, specifically object $, the variable, and that will give you the information. If you're going to be performing multiple operations on a single object, then you might want to attach that object. So for instance, you could attach a data set, and then you no longer have to refer to the data set. It's assumed that every variable you refer to in subsequent commands is coming from the attached data set. Again, that's a very useful command, useful shorthand. And then lastly, we're going to be loading and working with a lot of shapefiles. And down here at the bottom, I've got a couple commands for how to write or generate a new shapefile after you've performed multiple operations on it. So maybe we'll load a shapefile into R, perform several operations, generate new variables, maybe generate some new characteristics or properties of the shapefile. We don't want to lose all that information. We'd like to be able to save that shapefile as a new, expanded, um, revised shapefile, and we can do so with these commands and then open that shapefile in Geoda or ArcMap or some other software that requires a shapefile. So those are some helpful commands for starters. Another orientation piece or a bit of information, introductory information for R, is that it requires you to install packages before you can use or execute them. Again, if you're familiar with Stata, Stata has a similar structure where you need to install different packages of functions before you can employ those functions. Same concept here with R. So in R, the basic command here is install packages. One thing to always keep in mind is that it's not enough to install the package. You have to install the package and then open it. And the command for opening a package is library. So for instance here, we install the package SP, which is a spatial analysis package. It's installed, but then down here you'll see we want to open it. So we open library SP. As I noted before, you can highlight a huge section of your R script and then just hit Control R. Again, I imagine that that's Command R in Macs, although I have not worked with a Mac in a long time. So here we could highlight install all of these packages, and then I'm just going to hit Control R. It's going to ask me to select a CRAN mirror for accessing these files. I'll pick the first one from Pennsylvania, which I believe is the closest one, and it'll start installing all of these packages. Technically, this is not necessary for me to do on my machine. I've already installed these packages previously, and so once you install a package, you don't have to install it again. It's on your hard drive, or it's in your home folder for R. So technically, I would only need to open these packages using the library command. However, I'm just demonstrating how to install, so that R just finished installing all those packages, and then we can highlight all of these library commands, and again hit Control R, and R will open all of these packages and make them usable, accessible. You'll see a couple of error messages up here with regards to these two, with read Geoda and read gal. Some of these packages are old, no longer exist, and that's because they've been incorporated or integrated into other larger umbrella packages. For instance, I believe read Geoda and read gal have been incorporated into the spdep package, which we loaded previously, so they should be accessible there. I'm not quite clear which packages get integrated or incorporated into larger packages, so I've gotten in the habit, maybe it's a bad habit, of just leaving these here, but at least this way I'm assured of not missing something if some package gets separated out from a larger umbrella package. Anyway, that just explains that error message. Here you have a reminder of that error message. And then one thing that is included in one of these packages, the spdep package, is a set of sample data sets. So it's a little bit redundant, but for instance, there is a sample data set called Columbus, which I believe has housing values in the city of Columbus, Ohio. So if I highlight that and click Control R, it'll give me access to that data. I can summarize the variables in that data by using the summary command. And here you see it gives you a distribution for each of the variables in the Columbus dataset. And it is a housing value dataset. This HOVAL variable is a housing value variable income, crime. This is basically data used to estimate housing values, I believe. So the summary command is a nice command to remember if you've loaded a data set and you just want to get a quick look at the distribution of your variables. You can use summary. You can also use names to get a quick list of all the variable names if you're trying to specify a regression or look at some correlations or do some other operation and you can't quite remember the name of a variable. You can get a quick list of all your variables there. You could also use head Columbus, and this will give you the first 5 observations, or the values of the first 5 observations. Let me just run this. Yeah, so it gives you the first 5 observations under each variable. And those are some nice introductory commands. And again, to install, to work with the package, you need to install the package and then open it with the library command. I strongly recommend that you use a working directory. Many of the commands below assume that you've set a working directory and have all of the replication files from Blackboard saved in that working directory. So here I'm going to repeat the command that I illustrated earlier, get working directory. I just highlighted it, so I'm going to hit Control R. Here you see on the left my current working directory. I want to change that to my replication folder for Baller et al. So I'm going to highlight that, set working directory command. Note that this is my working directory. Do not use this same location or destination for your working directory. Use the folder on your own machine. So here I'm going to hit Control R. I've changed my working directory. Now I can repeat the get working directory command, and you can see that it's changed. If I have any doubts, I can list the files in that directory. There they are. There's the national homicide data set, and I can also hit directory, which gives the same thing. So those are all preparatory steps, right? Installing software, opening the software packages, setting up your working directory, some helpful commands. Now we're actually going to start loading and manipulating the homicide data from Baller et al. So again, you should have downloaded this data from Blackboard. You should have it in a single folder, which you've now set as your working directory, and you can get some descriptive info on the shapefile with the getinfo.shape command. I'm going to hit Control R here, and here it gives you just a basic description of the file. It's a polygon shapefile with 3085 shapes. This might be important if you weren't quite familiar or if you'd gathered some new data and just wanted some basic descriptions of it. But now we're going to use this read shape spatial command to load the national homicide shapefile using the unique ID, the FIPS number. And in R, you basically set a name for an object. This name could be anything you want. You can call it something different if you'd like. I'm just using an abbreviation that helps me remember what shapefile I'm referring to. But this is basically the object name. The back arrow here tells you that this object is going to be constituted by whatever comes after that arrow. So we're going to execute a function to load a file with this ID number and these specifications, and everything on this side of this back arrow is what is going to create this new object NAT. So let's highlight the whole thing and hit Control R. You can see on the left the new cursor appears, no error messages, so it executed fine. And now we can execute some of those summary commands, right? We can summarize our new shapefile. So there's our data. Here's an overview, summary statistics, and has our county names, state name, state FIPS, county FIPS, FIPS, state FIPS, our unique identifier FIPS number, the region dummy, and the homicide rate for 1960, and so on. Again, if we couldn't remember the name of a particular variable, we could do names. Oh, it didn't create, I skipped a step here. So NAT is our shapefile object. We can extract just the data frame, just the data set, the DBF data from the shapefile by using this data frame command. So now this new object, nat.data, is constituted by the data frame from nat. So let's execute that, Control R, no error messages, and now we can get the names from nat data. There are variable names. We can get the first 5 observations. There's our first 5 observations, and so on. And then we can attach this data set. So let's go ahead and attach it, then we won't have to reference it down the road. Remember that you've attached this data set, so if you want to work with a different data set in the same workspace, you've got to remember that this data set has already been attached, so you can't just specify variables from that new data set. Here are some other commands you can try if you're certain that it's a polygon shape. We could have used read shape poly instead of read shape spatial. You can also use read OGR. Loads more information if that information is in your original shapefile. And then you have other ways to read data. You can read CSV files, you can read stata files, you can read all sorts of different file formats. This is just one example. So with our shapefile in memory, we can quickly do something similar to that confirmation that Geoda did by plotting a themeless map. We can quickly plot a themeless map to make sure that we're working with the correct geometry. So we could just simply plot nat. I'm going to hit Control R, and here you see our map appearing in the top right, as I mentioned before. So the default setup is for the workspace to be on the left, and for graphs to appear on the right, and for your R scripts to be somewhere in the middle. I like staggering them just slightly so that I can always click on one or the other windows and be able to see what's going on. So this map quickly confirms, this themeless map of the United States quickly confirms that we're working with the right geometry. You can leave this open or close it. I'm just going to close it here and move on with the R script. One thing you can do if you have more than one graph, or you want to compare a couple graphs side by side, is to use this command to partition a window or a graph frame to include 2 images. So here basically we've got this set up to include 2 rows and 1 column. So it's going to create a new sort of graph frame with 2 rows and 1 column. You could change this to anything you wanted. If you wanted a 2 by 2 setup, you could have 2, 2 here. Or if you wanted 3 rows and 2 columns, you could do the same thing. But basically, let's stick with this for now. So I'm going to hit Control R. So this starts our graphing frame with 2 rows and 1 column. And then in the top row, I'm going to do our basic graph. So in the top row, it's creating our basic themeless geometry. And then in the bottom one, I'm going to create the same thing, but just with some axes. Oh, sorry, not axes. With the labels, with the county name. So as you can tell, the labels, as you include the name of each county, it really obscures the map. This is not a very useful map, but it just illustrates the point that you can generate 2 graphs side by side. You could expand this to take a closer look, and there you can kind of start to see a little bit more detail in the county names. But again, this bottom graph is not a very useful graph at all. It just illustrates the point that you can separate the window and plot more than one graph at the same time. So I'm going to stop this video here because it's already a little bit over 20 minutes, and I'll come back in the next video and talk about generating spatial weights.